Welcome back, Focus Learners, to another explainer. Today, we're looking at a massive, and I mean massive shift in how the world's most advanced data centers are actually being built. We are talking about the brand new engine behind the next generation of artificial intelligence. It's the NVIDIA Vera CPU, and it's been purposefully built from the ground up as the CPU for agents. If you've been following the AI space at all lately, you know the computing demands are just skyrocketing, and the physical hardware literally has to evolve to keep up. Okay, let's dive into this and see exactly how NVIDIA is engineering the physical future of AI. So here's our roadmap for today. First, we'll cover the rise of agentic AI. Second, we'll look at the CPU bottleneck. Third, we'll officially introduce the Vera CPU. Fourth, we'll take a deep dive into the breakthrough architecture and specs. And finally, we'll look at how this is powering global AI factories. Section 1. The rise of agentic AI, moving beyond the model. AI is no longer just about generating a clever block of text in a chat window. It's really about actively doing things out in the world. But to understand the new hardware, we first have to define what the software is actually doing. Agentic AI refers to workflows that require intense, behind-the-scenes CPU work. We're talking about real-time code execution, using digital tools, spinning up sandbox environments, crunching heavy analytics, and orchestrating massive data pipelines. Think of the modern data center as a giant AI factory. In this factory, the GPUs are the heavy machinery doing all the raw brute force processing. But every highly automated factory absolutely needs a manager, right? Someone to orchestrate all these complex software tasks and keep the entire assembly line moving smoothly. Well, that manager is the host CPU. But here is the multi-million-dollar problem the industry is currently facing. What's actually holding these AI agents back right now? Why can't we just scale up our current systems infinitely and call it a day? This brings us to the real villain of our story. Section 2. The CPU bottleneck, when the factory manager falls behind. Let's compare modern agentic workloads with our traditional setups. Across a single agent's reasoning loop, a CPU has to compile generated code, run complex Python toolchains, and constantly evaluate software at literal lightning speeds. The issue? Traditional x86 CPUs using standard DDR5 memory simply weren't built for this kind of relentless control-heavy traffic. They force a pretty brutal trade-off between memory bandwidth, power efficiency, and serviceability. So when the host CPU gets bogged down trying to manage all these simultaneous tasks, the whole reasoning loop bottlenecks. You end up with incredibly expensive GPUs just sitting there, waiting for the CPU to catch up. And in the data center world, waiting means wasted time and a whole lot of wasted money. Section 3. Entered the Vera CPU, the ultimate AI factory manager. Now, what's really interesting here is the sheer scale of the performance leap. NVIDIA Vera actually accelerates agentic sandbox performance by up to 1.8 times over leading x86 CPUs by completely turbocharging that agentic inner loop. The compiling, the Python toolchains, the deep software analysis. Vera massively increases the overall output of the entire AI factory. The agents spend way less time waiting, and the systems can generate far more feedback per training step. Like we mentioned, standard servers rely heavily on DDR5, which brings some serious efficiency trade-offs. But NVIDIA Vera flips the script. It shifts to LPDDR5X memory and pairs it with SoC-AM, which is this really clever modular socket technology. It gives you low power efficiency but keeps that essential server-class flexibility. This shift alone delivers twice the overall memory bandwidth, and get this, an incredible 3 times the bandwidth per core compared to leading x86 CPUs. More bandwidth means faster data retrieval, which ultimately means your AI factory generates significantly more tokens for every dollar you spend. Section 4. Breakthrough architecture and specs. Let's look under the hood. There are basically 4 core technological pillars holding up the entire Vera architecture. We just touched on the LPDDR5X memory, but that works in perfect tandem with custom Olympus cores, the second-generation scalable coherency fabric, and NVLink C2C connectivity. Let's break down why each of these pieces is absolutely crucial for keeping these massive software environments responsive. First up, the cores. Vera features 88 custom-designed Olympus cores. These aren't your run-of-the-mill general-purpose cores. They are built specifically for the control-heavy, incredibly latency-sensitive work of reinforcement learning. But actually, it doesn't stop at 88. By using NVIDIA spatial multi-threading, which efficiently partitions the core resources, those 88 cores effectively create 176 threads. That gives the whole system highly predictable throughput at a massive scale, letting thousands of parallel tool calls and evaluation loops complete way faster than before. We talked a bit about the LPDDR5X memory earlier, but let's look at the raw speed. Vera pushes an astonishing 1.2 terabytes per second of memory bandwidth. To put that into perspective, that is like downloading 250,000 HD movies in a single second. It's wild. And the crazy part? It does this while operating at half the power of traditional CPU memory. When you're actively managing up to 1.5 terabytes of total memory capacity for data-intensive workflows and cache management, doing it at half the power consumption is a total game changer for data center sustainability and your bottom line operating costs. Next on the list is the second generation SCF, or Scalable Coherency Fabric. Think of this as the digital superhighway connecting all 88 of those cores, the cache, the memory, and all the input-output channels. So the crucial point is this. All of this sits on a single monolithic compute die, pushing an insane 3.4 terabytes per second of bandwidth right across the chip. Because everything is completely unified on a single die with a unified cache architecture, the system entirely avoids that nasty latency you get jumping between separate chiplets. The cores have fast, consistent access to their data, even when the CPU is completely maxed out. Finally, let's look at how this builds out into the broader system. Standard data center setups usually have somewhat isolated CPUs and GPUs, which creates these terrible data transfer bottlenecks when you're trying to move massive data sets back and forth. Vera completely bypasses this using NVLink C2C. This delivers up to 1.8 terabytes per second of coherent bandwidth directly between the Vera CPUs and the NVIDIA GPUs. When you pair Vera with NVIDIA Rubin GPUs, it basically creates a unified memory architecture. The CPU and GPU just seamlessly work together on complex AI workloads without tripping over those awful data transfer traffic jams. Section 5. Powering Global AI Factories. From announcement to production. All right, let's zoom out from this silicon die and look at the real-world deployment, because this isn't just theory anymore. For true hyperscale needs, NVIDIA designed the Vera CPU rack. Built on the NVIDIA MGX modular architecture, this incredibly dense, liquid-cooled rack integrates up to 256 Vera CPUs. Think about that for a second. A single rack can run over 22,500 concurrent sandbox environments. It's essentially an entire AI factories management system compressed into a single data center footprint. But the true flagship of this hardware generation is definitely the NVIDIA's Vera Rubin NVL72 platform. This unifies 36 Vera CPUs and 72 Rubin GPUs running right alongside cutting-edge networking tech like ConnectX-9 and BlueField-4 into one massive rack-scale system. In this specific setup, Vera acts as the absolutely perfect host CPU. It consistently feeds those 70 GPUs, runs massive data extraction pipelines, handles the orchestration, and just scales up the whole system's intelligence seamlessly. And the industry's already putting this exact hardware to work. Just to ground this explainer in reality, Ian Buck, NVIDIA's VP of Hyperscale and HPC, literally just hand-delivered the very first NVIDIA Vera CPU systems to Anthropic, OpenAI, Oracle Cloud Infrastructure, and SpaceX. That's right, the biggest names in AI development, cloud infrastructure, and aerospace are already utilizing these physical systems in their actual production environments to train the next generation of agents. So we've seen how agentic AI requires a totally new kind of factory manager, and how the custom cores, the massive memory bandwidths, and the unified architecture of the NVIDIA Vera CPU provide exactly that. It's a tremendous leap forward in keeping those expensive GPUs utilized and keeping the training loops moving fast. So I'll leave you with this final thought to consider. As AI workflows evolve rapidly from simple generation to complex, active reasoning, is your data center ready for the age of AI reasoning? Thank you for joining me on this explainer, Focused Learners. Keep learning, keep optimizing, and I'll catch you in the next one.